Hello students, welcome back to my channel. In today's session, we are learning another sorting algorithm, and today's algorithm is called as shell sort. So this algorithm is sometimes also called as sorting by diminishing increment. So just like how we have learned in the previous session, this is once again another sorting algorithm where we will have a set of given integers in a unsorted way, and we need to apply certain methodologies or techniques in order to sort them. So this particular method is called as a shell sort, where we will be using a certain number of a gap or an increment, and we are going to diminish it. Diminish as in we are going to reduce that gap or increment, and with the help of that, we will try to sort the given array. This is a kind of a insertion sort which we have learned in the previous session. Why? Because as and when we move to the end of the algorithm, our algorithm starts behaving like a insertion sort that we will see. So as of now, let us start with the shell sort. So what is a shell sort, or who has invented it? Okay, a shell sort is conceived by Donald Shell in 1959. It is an in-place comparison sort, as in within the array itself, we will be doing the comparison and moving. We do not require any additional arrays in order to do that. It is an enhancement of insertion sort, just like I told you. Okay, allowing the exchange of the items that are far apart. This diminishing increment approach helps to reduce the number of shifts required for smaller element to reach their correct position. So what does this mean is, for example, if I have to take an array 10, 2, 23, and 5. The insertion sort, what we have learned in the previous session, we knew that initially we will take an element as a key, and we will assume that this is sorted and these are unsorted, and we will take next element and then we'll start comparing. So I'm going to compare. The moment I find that this element is bigger than that, I'm going to exchange it. Next, I will once again compare same element with the other unsorted one. So as of now, I will consider this as sorted. Next, I was considering these as unsorted. I will take the next element, compare it with this, and then if it is smaller, then I'm going to shift. So in this case, I'm going to keep it as it is. Next, I will take 5. 5 I'm going to compare with 23. It is smaller, hence I'm going to swap 23 and 5. Next, I will compare 5 with 10, and then I'm going to see that yes, 5 is smaller than the 10, and what I'm going to do is I'm going to shift this. So 23 will be shifted to this place, 10 will be shifted to this place, and I will make place for 5, and I'm going to place 5 here. So what was happening is, if at all we had a very large number of elements, in that case, comparison as well as movement of each element was taking very long. So shell sort is a improvisation over the insertion sort. Here, what we are going to do is we are going to take something called as a gap, or in some textbook you would also see it as an increment. This is a value what we are going to take. For example, if gap is 3, I'm going to compare the first element with the third element, and then I'm going to compare and see that which is bigger, and I'm going to exchange. Okay, we will see that in detail. So there is going to be something called as a gap sequence. The core of shell sort lies in its gap sequence. Okay, so it is totally reliant on the gap. The efficiency of the shell sort also totally depends on the gap. Okay, the kind of gap we are taking. So initially it sorts the element far apart, then gradually reduces the gap until it reaches 1. By moving element across the large distances early on, shell sort significantly reduces the inversions, making the final insertion sort much faster. So when we were learning insertion sort, we had learned that whenever there is a large number of comparison to be done, as in large number of swaps to be done, if the efficiency decreases for insertion sort. Insertion sort is very efficient only when there are fewer exchanges or almost sorted array. In such situation, insertion sort always gives a best result. Now, what a shell sort does is it'll apply the gap sequence method until its last step, and in the last step, when The array is almost sorted. We will apply the insertion sort and hence it will become very efficient. Okay. Also, shell sort performs its operations directly within the original array, requiring minimal additional memory space. Just like our the previous insertion sort, we do not require additional array. So, whatever the memory which has been allocated initially itself is sufficient for us to do the sorting. Okay. So, let us see the steps required or the increment, the main principle which is works on shell sort. So shell sort sorts the elements that are certain gap apart. Imagine sorting subarrays, each containing element separated by a fixed interval. Now, what is the meaning of that? Suppose I'm taking gap as 4. Okay, so this is the zeroth element 1, 2, 3, 4. Next, I will be comparing 35 and 14. So the gap here is 4. Next, 33 will be compared with 19. Once again, as you can see, the gap is 4 here. 42 will be compared with 27 and 10 will be compared with 44. Okay. Now, what do you mean by comparison? Unlike insertion sort, I'm going to compare these two elements. So I find out that 14 is smaller than 35. So 35 will be replaced by these both will be swapped. All right. Similarly, 33 and 19 when I'm comparing, 19 I can bring it here and 33 can be brought here. Next, 42 and 27. Of course, 27 will be brought here and 42 will be over here and 10 and 44 will remain. So now if you see, I have a better array here just by three swaps. Three swaps and three comparison. After completion of that itself, I have a better sorted array. Of course, it is not completely sorted, but this one is better. All right. Now, what I'm going to do is I'm going to reduce, just like we say that diminishing increment, the increment value or the gap value will be reduced. There are many ways to, first of all, decide what can be the gap and how can we reduce the gap. The very common one, what we do is we will divide it by 2 or we will make it half. So, of course, next gap is going to be 2, which means I'm going to compare this and this. This and this will be compared. Okay. 27 and 33, 10 and 42, 35 and 44. So this will go on like this. So every two gap I'm going to compare. Now once again what I'm going to do is I'm going to compare and whenever I find that the previous value is smaller, I'm going to swap it. Now after considering this, once again gap will be reduced to 1. The one gap is nothing but I'm going to compare next to each other. So this is the whenever your gap will reach 1, it is automatically nothing but it is our insertion sort. So we will apply this insertion sort and then we will have a sorted array. So as you can see, if in case it was an insertion sort, we would have had many passes and in every pass we would have had lot many comparisons and swappings. So instead of that, we are going to reduce it drastically, the number of comparisons and the swappings. Okay, so let us see the main steps. So initially, we will take a large gap. Elements are compared and swapped over the large distances, quickly moving misplaced items close to their final positions. Reduced gap, the gap shrinks and the algorithm performs more localized sorts on the partially ordered data, similar to insertion sort. And then final gap, the last pass with the gap one is essentially the standard insertion sort on a nearly sorted array, which is highly efficient. We have seen that always insertion sort is very efficient when the array is almost sorted. So we are going to apply that and get a best result out of our sorting algorithm. Okay, so let us see one example. So let me take gap as 4, 4 itself here. So initially I will take certain I value and I will take j value as a gap. So this is nothing but I will start with 0 and j will be, of course, which will be 4. Now what I'm going to do is I'm going to compare 35 and 14. So as you can see that obviously this is going to be exchanged. All right, next what I will do is I will increment the I value. Similarly, I will increment the j value and I'm going to compare 33 and 19. And as you can see, 19 is going to come here and j value, which is this is going to be 33. Next, I value will be incremented to 42 and j value will be incremented 27. So 27 is going to come here and 42 is going to come here. Next, I value will be incremented over here and then j value will be incremented over here. So 10 and 44 when I'm comparing, what is going to happen is this is not going to do any changes. So as it is, I'm going to write. Now, remember when I'm incrementing this value to I, j value will be incremented over here and I realize that j value is now greater than n minus 1. So we have to, this is a stopping condition for us always. J value, sorry, this is j values should be always less than or equal to n minus 1. The moment it is crossing, it is becoming greater than n minus 1, we will realize that there is no more element here and we will stop the comparison. Okay, so immediately my gap will be now reduced to will be made by 2, which is nothing but 2. Now my gap value is 2. So once again I will start with the I. J value is going to be here. Now what I'm going to do is compare 14 and 27. Of course there are no changes, so it is going to remain as it is. So 14 over here and 27 over here. Next, I value will be incremented here, j value will come here. Now, what is going to happen? Of course, 10 will come here and 19 will be moved here. Now, I value will be incremented here and then j value will be incremented here. I'm going to compare 27 with 35 if there is no changes. So, as it is going to remain as it is. Okay, now I value will be incremented here, j value here. Once again, no changes. Okay, now we should take care of this that I value was here. Remember, we have moved the value. So I value was here, j value is here. There is no changes. Again, I value will be incremented, j value here, no changes. I value here and j value here, no changes. And j value is going to now exceed and then we will stop. Okay, as you can see that our array is completely sorted. So when the gap becomes 1, we are only doing the comparison here. Okay, so when I'm doing the initial comparison itself, I'm getting this as 14 and this one is similar. Next, I will compare 14 with 27. This is in a proper sorted way. 27 when I'm comparing with 19. Okay, this needs some exchange. All right, 27 when I'm comparing 35, this doesn't need any exchange. 35 when I'm comparing with 33, of course, this need an exchange. So basic exchanges, whatever is required, is only done here. As you can see, fewer, very few. So when I say that gap is equal to 1, it is nothing but I'm just comparing the neighboring uh, uh, values. I'll compare and I will exchange. This is nothing but our insertion sort. If you can remember this, it is fine. Otherwise, you can simply remember that gap is equals to 1 and you are doing the comparison. So as you can see, by the end of the algorithm, your array is sorted. There are no much steps here as if we had in the insertion sort, but then this is simply done very easily. Now, this particular kind of a shell sort is once again is useful for very small and medium arrays. It is not very good or efficient for large data sets. Always for large data set, your bubble sort or quick sort is efficient. So let us go ahead and see the shell sort algorithm. Let's take the same example 35, 33, 42, 10, 14, 19, 27, and 44. Now remember the index for this. This is 0, 1, 2, 3, 4, 5, 6, and 7. Okay, so let us start. So initially gap is going to be initially 4. Let us take it as 4. And then remember always gap should be greater than or equal to 1. That is because the moment we reach 1, once we complete the sorting for gap 1, which means that our array is sorted. So we need not go further. We need not go for 0 or minus 1. So the moment we reach equal to 1, we are completed the sorting. That is the reason always our gap should be always greater than or equal to 1. Next, we will start with the j. Now, j loop is telling that j will start from gap to n minus 1. Now, what is a gap value? Gap value is it is 4. So j will be over here. It is going to continue until n minus 1. That means it is going to go up till here. Okay, so that is where your j will start. Now, inside this j loop, we have a for loop. And as you can see, the I value is nothing but j minus gap. Now, what is j? J is nothing but 4 minus gap is nothing but 4 once again. So, which means 0. So, it is nothing but my I value starting from 0. That is the reason we are put here in this way. Also, always make sure that your I value is either greater or equal to the 0. It cannot be negative value. Now, can it reach a negative value? Of course, because we are going to calculate the increment of the I value in this way, that is I minus gap. So you'll understand as and when we iterate that why we are doing that. But as of now, you understand that the initialization of I value is ij minus gap, and then it should always be positive value. All right. Now, let us do for j is equals to initially 4. Now, what is going to happen? So, the moment I have a I value and j value, like I told you, we are going to do the comparison of the value. So, I'm comparing, as you can see here, if a of I plus gap. Now, what is I value? 0. I plus gap is nothing but this value itself. So, I'm comparing j with a of I. And if at all I find that j is greater, here remember the j is also called as I plus gap is nothing but your jth position. If this value is greater than this, which means that it is in a proper ascending order, I need not perform any action. That is the reason. If a of I plus gap is greater than a of I, we will break. Otherwise, which means it is in a different position, I need to swap. So else we are going to swap those values. All right, so let us see if 35 is greater than 14. Sorry, it is a of I plus gap. That is, if 14 is greater than 35. So in this case, it is false because 14 is not greater than 35. Hence, we are not going to break. Instead, we are going to swap the values. So which means now, after this particular for loop, I 14 is over here and 35 is swapped over here. What happens next? I perform this, which means I'll go back to the for loop and I will change the value of I. Now, what is the changing value? I is equals to what is the existing I value minus 4, which is nothing but it will give me negative value. And remember that the moment I get a negative value, I need to break out of this loop. So I will break out of this loop and go back to my jth loop. So which means now I'm starting with the second time in getting inside the jth loop. Now, once again, what is going to happen for j is if j value is going to be simply incremented to, it will be now j is equals to 5. Now, once I change the value of j, once again, I will enter into the I loop. So I is going to be j minus gap, which is nothing but 1, which means now I value is moved over here. And of course, j value is increment. This is just like how I told you before. We are going to simply increment and compare. Okay, so once again, compare the value of 33 and j. As you know that this has to be swapped, hence we will swap. So 19 is going to come over here and 33 is going to come over here. So once that is done, once again, we will go back to the I loop and I will check that I is equals to current I value is 1 minus gap is nothing but 4 and it is minus 3. Now, what is the reason of checking this negative value? Now, negative value simply indicates that there are no element behind this, as in I is over here, there are no values here. But the moment I reach the gap or I cross the gap, I will also going to be compare the values behind it. That is the reason we are doing it. Okay. So I'm comparing this negative value, hence I will exit out of the for loop. Next, third pass, j is going to be 6. J is going to be 6, I is going to be 6 minus 4, which is nothing but 2, which means now I is over here and j is over here. Compare 42 and 27 and we realize that they both are in not the correct position. So 27 will be moved here and 42 will be moved here, which means I'm going to perform this. When I check this condition, I realize that else part is going to execute. Hence exchange is done. And next what is going to happen? Increment the I value using this condition. So I is equals to I minus gap. Once again, I'm getting a negative value. I will simply break out of this loop and go back to the for loop. So jth for loop. So j is going to get incremented to 7, which means j is over here now. Now what is going to happen? I value I'm going to check. I is equals to 7 minus 4, which is nothing but 3, which means I will be moved here. Once again, comparing and seeing that a of I plus gap is 44 and a of I is 10. And this is greater than a of I, which means that it is in a proper order. Hence, we are not going to perform any swap operation. All right. So next, after this, what? No swap, which means we are going to break. So when we break, which means we are going back to the for loop and we are simply next calculating the I value. So I value is, this was nothing but 3. So I value now it is going to be I minus gap, which is nothing but minus 1. It is a negative value. Of course, the condition fails. Hence, we will go to the outer jth loop. So outer jth loop is nothing but now j value is going to get incremented to 8. So when it is getting incremented to 8, we know that when we are checking the condition of n minus 1, this fails because n value is 8 and n minus 1 is nothing but 7, and we cannot have a j value crossing the 7 because which it is indicated that I have reached the end of my array. Hence, I will break out of this for loop also. So when I break out of the for loop, I will go to the next step, which is nothing but decrease the gap by the factor of 2. So by the completion of this particular uh, step, this is my sorted array looks like. So it is 14, 19, 27, 10, 35, 33, 42, and 44. So this is for gap 4. So next what is going to happen is we are going to decrease the gap by 2. So 4 by 2 is nothing but now gap is going to be 2. So once again we will follow up the same thing. So what is going to happen now? Once again j value. So initially j value is going to be nothing but gap. Gap is nothing but 2. So this is 0, 1, 2. My j value is going to be here. I value is going to be 2 minus 2, which is nothing but 0. Why 2 minus 2 is nothing but j minus gap. As you can see here, it is going to be j minus gap. Let me clear this. So j minus gap is nothing but now current value of j is 2 and the value of gap is 2. Hence it is going to be 0, which is nothing but my uh, iteration is going to start from here. So I'm going to compare these two just like before. And then as I'm finding that it is in the correct order, I will not swap. I will simply increment the I value. I value is once again, it is coming as 0 minus 2 is nothing but minus 2. Hence, I will simply increment the jth value. Now, j is going to be 3, which is nothing but j is over here. And now I is going to be 3 minus 2, which is nothing but 1. Hence, I have incremented the I value. Compare 19 and 10. As you can see that, of course, there is a swap required. Hence, 10 will be moved here, 19 would be moved here. And then increment the I value. I is equals to I minus gap, which is minus 1 negative. Hence, we will go and increment the value of G to 4. So, G is over here. Now, I value is going to be 4 minus 2, which is nothing but 2. Again, now I value is over here. And then I'm going to compare. J value is 4. So 0, 1, 2, 3, 4. Sorry, J value is here, 35. I'm going to compare 27 and 35 and I see that there is no swap required. Hence, I will simply increment the I value. Now you see what is going to happen is I is going to be the value of I was 2 minus 2 minus gap is 2, hence it is 0. Now 0 is satisfying this condition. So which means what I'm going to do, I'm going to once again compare I value is now changed to 0. Okay, it was 2 before. Now, once again, I value is over here. I am going to compare this value with A of I. That is, A of I zeroth value plus gap as in this value. Once again, we are backtracking it and then we are doing the comparison here. So when I'm comparing 14 with A of A of 0 is 14 and A of 0 plus 2, which is 27. I'm comparing. They are in the right position. Hence, I'm going to leave it as it is. Once again, increment the value of I, 0 minus 2, and it is coming negative. Hence, I'm going to stop. Okay. Next, I will simply increment fourth iteration. J, it is going to be 5, which means J is going to come over here. And I is going to be 5 minus 2, which is nothing but 3. So 0, 1, 2, 3. Now I'm comparing 19 with 33. As you can see, there is no swap required. Now I value I'm going to once again increase as this is going to be 1. So what is going to happen? Now I'm comparing 1 with 1 plus 2. That is 1 plus 2 is nothing but 3. So I'm comparing 1 with 3. So I'm comparing 10 with 90. All right. So as you can see, I'm not just going ahead and checking with the next element. I am also coming back and checking with the previous element. Okay. So this is what is this particular value is representing. So I'm going to compare 1, that is 10 with 19. And as you can see, there is no swap required. Once again, what I will do, I will make it 1 minus 2, but this is negative value. Hence, I will stop. Okay, why this is we are getting negative value, which means there is nothing behind this. So after 1, if at all my position was 2, I would have come back to 0 and I would have compared. So as and when I'm going forward, I'm also coming back 2 gaps behind and going on checking with the comparison of the element. All right. So in this way, this will continue all the elements we are going to compare. Okay. So if you want, I will just quickly do it. So fifth one is J is going to be 6. So 0, 1, 2, 3, 4, 5, 6. So J value is over here. And hence I value is going to be 6 minus 2, which is nothing but 4. So which means we are over here. 35 and 42 is compared. There is no swap required. Once again, I value is going to be changed to 4 minus 2, which is nothing but 2. So as you can see, so I'm comparing this particular value with this as well as I'm comparing 2 position behind, and also this time I'm going to compare over here. So it is not just the gap ahead, I'm also going to compare with the gap. So this is a 2 gap, this is a 2 gap. Okay, so nowhere there is the requirement of the exchange. Similarly, when I come over here, I'm going to compare with this, I will compare with this, I will also compare with this. So every 2 gap I'm going to go on comparing. Sorry, not this one. It is 33, right? So I'm going to compare it with 19. I'm also going to compare it with this value. So when I complete this, what is going to happen is we will be getting a array where there is all the comparisons will be done, and then our array will be in this manner. By the time we complete, my array will be, I'm going to write over here, array will be 14, 10, 27, 90, 35, 33, 42, and 44. As you can see that it is almost sorted. And now the gap value will be divided by 2, which is nothing but 1. Now I'm not going to do all the iteration, you can do it. So now what is going to happen is I will take this as I, this as J, and I will compare. And of course, there is going to be change, isn't it? And similarly, next what I'm going to do is I value will come here, J value will be coming over here. We are going to compare this, and also I'm going to compare this. Similarly, I value will come over here, J value will come here. I'm going to compare this with this with this, also this with this. So I'm going to go on do that, and then at the end of the day, I'm going to have a sorted array. So this is how a shell sort works. It is very simple provided you remember are we going to remember the I value increment or decrement. Otherwise, it is a very simple array where we are simple sorting algorithm where we are going to have an idea, or we are going to remember that there is a gap which is diminishing or it is decreasing, and then we are going on comparing. So unlike insertion sort, we are going to have an efficient array. So let us have a look at the time complexity. Time complexity, as you can see, the worst case is order of n square, average case is order of n log n, and the best case theoretical also it's going to be order of n log n. Okay, so always remember that shell sort is totally dependent on the gap sequences. So what kind of a sequence or a gap you are taking, depending on that, the efficiency also varies. So it is very important to decide on what kind of a gap you are taking. Okay, so if it is a very small array, if it is a medium array, the shell sort is very efficient. But when compared to the a large element, it is not as good as other arrays. So let us see the advantages. It is efficient for medium-sized data sets. In-place sorting. Okay, so there is no much memory required. It is faster than the basic insertion, bubble sort, and selection sort. Relatively simple to implement. At the same time, we have it is complexity is highly dependent on the gap sequence what you're taking, because the more number of gaps, the more number of diminishing increment you are taking, the more number of complexity will increase. Not stable, relatively order of equal elements may change, not as fast as quicksort or merge sort for very large. So when it is comparing with the merge sort and the quicksort, if it is a very large data set, it is not as good as them. And determining the optimal gap sequence, like I told, it is always dependent on the gap sequence which you are picking. Hence, determining the best one is a problem, or it is an open problem, so it can always be decided. So what are the takeaways of this particular shell sort? It is an improved insertion sort using diminishing increment. Okay, performance is highly sensitive to the chosen gap sequence, like we told again and again, and good for moderate data sets and situations where in place sorting is prioritized over the guaranteed order of n log n performance. So these are the key takeaways which you can take from shell sort. So that's all in today's sessions. I hope I've tried to explain the shell sort in a as simple manner as possible. If you have any queries, kindly comment it in the comment section. So thank you for watching. Keep learning.